Hello there! This video will cover some of the universally applicable basics of programming. No matter which language you are aiming to become proficient in, this video should give you some solid basics which apply to all languages. I just want to quickly iterate that this video will not cover how to do something in any specific language. Rather, it will cover some general concepts applicable to all programming languages from which it should be easier to learn any other language. To program in any language, there are a few key concepts that one should grasp. No matter in which language you're going to be programming, these concepts will likely be present in some form, apart from extremely esoteric circumstances such as assembly. The first of these concepts are variables. Assuming you have had some degree of higher-level mathematical education, you will likely already know variables from algebra. Variables in programming are very similar. Typically, in all programming languages, to define a variable, there is a keyword, which varies from language to language. In the case of JavaScript, it is let, followed by a space, followed by the name you want the variable to carry, followed by an equal sign, followed by the value you wish the variable to carry. In other programming languages, you will have a different keyword instead of let. In Python, you do not have a keyword to specify a variable. Instead, you just say the name for the variable, followed by an equal to sign, followed by the value you wish to assign to it. In the case of some of the slightly more advanced programming languages, you won't simply be using let, but rather you will need to be using the keyword for which type of variable you wish it to be. As variables can store a variety of different data, if there is, for instance, a variable which is supposed to carry a number, then in certain languages you cannot use let, but you must instead use int, which stands for integer, which means any whole number. Variables are useful as they allow us programmers to capture a value generated at a specific point within our program and use it at any other point. Such as, for instance, in the case of a game, one might have a variable which represents the amount of money the player has. This variable can be changed to represent the player earning and losing money, and this variable can also be compared to other values, such as, for instance, checking if the player has enough money for something specific. Usually, you can create a variable without even assigning a value to it. This can be useful for certain scenarios, such as if you want to create a variable which you can only assign a value to at a later point, or at a point where otherwise the variable might get shadowed. Next up are naming conventions. Naming conventions are less of a concept in programming than something to keep in mind when programming. With naming conventions, there is no truly objective right and wrong. However, it is strongly advised to choose a certain set of them and only apply those, at least for a specific project. This is primarily relevant when using variables. When you name your variable, you may have noticed, if you've already tried so, that you cannot use spaces within your variable name, as the compiler interprets this as separators after the variable name and does not expect another name. So variables should always be named after a chosen naming convention. There are 4 primary naming conventions, which generally are considered to all have their own use cases. The first one is snake case. Snake case follows the convention that every letter is spelled lowercase in a variable name, and instead of spaces, underscores are used. The next naming convention is uppercase snake case. The only difference to normal snake case is that instead of spelling everything lowercase, you spell it uppercase. This naming convention is typically only used for non-changeable values, which only exist for, say, variables which are to represent a certain value which should never change. The next naming convention is camel case. In camel case, you do not have any spaces, they are just entirely omitted, and instead, every starting letter from a word is capitalized except that of the first word. And the final naming convention is pastel case. Pastel case is basically just camel case, except that you also capitalize the first letter of the first word. Pastel case is commonly used in scenarios such as object-oriented programming languages when naming objects. The main thing to remember with naming conventions is there is no right or wrong naming convention, but rather that you should choose which one you use and then be consistent with it. The next topic is loops. Loops are one of the most powerful tools for programming, and they are used for a wide variety of different use cases. Typically, programming languages have three types of loops. There are while loops, for-i loops, and for-object loops. These loops can be used to repeat a certain snippet of code for a certain amount of times. A while loop works by having a condition, and it will repeat the code within the loop until this condition is met. The next type of loop is a for-i loop. Commonly, any language has this. A for-i loop is initialized differently in different languages. However, the concept is that a for-i loop can be used to only repeat the code contents for a specified amount of times. And the code contents also have access to a variable, which represent the how many time the contents are being executed. So say if I had a for-i loop which executes 10 times, and what it executes is display the number, the how many time it's being executed, it would just count up. The last type of loop is the for-object loop. Not all languages have this, as it can very easily be emulated through the for-i loop. The concept of the for-object loop is that one can have a list of items. These items can be any data type. They can be integers, strings, or in some cases a mixture. And the contents of this for loop will be executed for each of the contents of the list, and they will obviously also have access to a variable which represents this object. Some languages, such as C, do not have this type of loop, as it can be easily emulated through the for-i loop. The way this can broadly be done is by, instead of trying to loop through the objects themselves, getting the number of objects, doing a for-i loop for that amount of objects, and figuring out which object you have by the how manyth object it is in the list. Following this, one of the most fundamental and important things within programming is the if statement. The if statement allows us programmers to let certain pieces of code only be executed under a certain condition, or to skip executing certain pieces of code under another condition. In all languages I've encountered so far, you have the same word for saying it's an if statement. It is literally just if, with the only difference being that in some programming languages you need to put the condition of the if statement inside brackets. If statements do some of the most things possible within programming. They can be used to check, say, if a player is attempting to purchase something, whether they have enough money, whether a player attempting to jump is on the floor, and a countless list of other things. They are one of the most important things possible. Something to keep in mind is that if statements expect to be given a Boolean condition. This means that whatever you write between the if and the then, or between the brackets in cases of languages that require that, has to be equatable to a true or false value. So say if you compare two numbers, whether they are equal, bigger or smaller, this can only be a yes or a no. Or if you compare two strings, it's the same thing. They can only be the same or not be the same. If you attempt to just put a value, say if you say if 1, then this will likely not have a desired effect. And what will often happen if you just put a variable, which is not a Boolean, then it is going to interpret this as you checking whether the variable has a value associated with it. Next up are functions. If you know what macros are, it is easier to think of functions as something similar. There are two things primarily that can be done with functions. When you define a function, you give it a name and you give it contents. These contents can be further lines of code which do certain actions. So say if you have a function to purchase an item, then within the function you would have all lines which do the necessary things when someone is purchasing an item. That would be deduct money and add the item to the player's backpack. And then the function could be called purchase item. So what can then be done is that if the player, say, clicks a button to purchase an item, you just call this function. Functions can be given what are called arguments. When you define a function, it will take what is referred to as a signature. This signature is the definition of the variables that will be available for use within the function and that need to be supplied when calling the function. So say if you're working in a language which has object-oriented programming, and then you have a object or item, so something someone can buy, then the function signature can be saying that it expects to be given an item, so that all the lines of code within the function can just assume to know what the player is buying, and then when you call this function to make the player actually buy an item, then when calling the function, you pass into the function the item the player is actually buying. There is another thing which can be done with functions. They can return. Returning is something that can either be done to exit a function at an earlier point, such as, say, if the player does not have sufficient amount of money, then there is no need to give the player the items and subtract the money, as they're just not able to purchase it, so it makes sense to cancel the function earlier. However, the primary function of returning something is so that the function can pass back a value. This can be, for instance, useful if you want the function to calculate a formula. So say if you have a calculate damage function, which takes in armor factors, damage factors, and health factors, and all the function does is it takes the health of the player, calculates how much damage the player takes, and then subtracts this amount from the taken health value, and then returns this health value. At the position in the code where this function is called, you can define a variable for what the function is returning. Something interesting is that these types of functions can very easily be seen as variables, as technically they have a return type, which means that they are just like normal variables, and if they return something, then you can simply define a variable by calling the function. The last thing that should be noted with functions is that they can be called recursively. This means that within a function, you can call the same function again. I'm aware that Python takes some issue with this, however I'm sure there's ways to make it work as well. So all in all, functions can be either used as a macro, or in case you have a formula which you need to calculate a whole bunch of times, so that you can instead pack this into a function, and then every time you want this calculation, just call the function, which is better for code legibility. There are two more topics left I'm going to cover in this. The last of which is less of a how programming works than just something that should be kept in mind while programming, similar to naming conventions. However, before that, I will cover debugging. Later on, there are more advanced ways to debug. However, for the scope of this video, I'm just going to be covering print statements. Considering you're likely learning how to code, it is quite likely that you've already seen the infamous print, "Hello World." You may be thinking that this is absolutely useless down the line. However, you may have already considered that you should print "Hello World" at certain different parts of your code, and then see how much of the code is actually printing. Another way this can be used is to track how a value changes. So say you could, before a function, print a value that will be affected by the function, and then after the function also print this value and see how it has changed. This can be useful in combination with printing a timestamp with each print message. In certain cases, the debugger will already be putting timestamps to every output in the console. However, that is not typically the case, so in those cases, you might find however your language specifically handles getting the current time and concatenating that with every print statement. For the purposes of debugging, print statements can be used to see which lines of code execute before a program crashes, to see how a value changes over time, and to provide general error messages. Not necessarily the error message that caused the program to crash, but rather in case you want to check a value to see why something specific is happening to it. The last thing I will be covering in this is formatting. Similar to naming conventions, there is no real right and wrong way to format your code, but it is imperative that you stick to one way of doing it. There are a couple of different things to formatting. There are indents, empty lines, multiple arguments, braces on new lines, cases where you might not even need braces, and spaces between characters. I have kind of not said the truth that there's no right and wrong. Stuff like indents is just, if you don't do them correctly, that it is horrible, which is the first thing I'll be talking about. Say you have an if statement. All the contents of this if statement speak everything that should execute it under the condition of the if statement is considered inside the if statement. And by being inside this if statement should be indented further than the contents are outside and including the if statement. This also means that if you have an if statement within an if statement, the first if statement has a certain indentation level and its contents have one further, including the if statement within there. However, the contents of the nested if statement should have another indentation level. This is very important as it helps with the legibility of your code, where you can see how deep something is nested by just looking at the indentation level instead of trying to find where the ifs and the ands and the opening and closing braces are. Empty lines. This is one of those where there is no right and wrong. You will likely want to be adding empty lines between certain parts of your code to separate them, such as how you might separate some variables from the usage of the variables, or the definition of some functions from the rest of the code. Over time, you will likely be tending towards not having massive amounts of empty lines between certain things, and I personally would recommend to never have more than 2 lines of a gap. Multiple arguments. When you call a function which has 10 different arguments you're passing to it, you will have likely noticed that this creates an incredibly long line of code. What is advised to do in those cases, and which should be doable in every single language I've seen so far, is that after each comma you can drop a new line so that each new argument is on a new line. If this then makes that you have way too many lines, you might experiment with having every second argument be on a new line, so that you always have 2 arguments per line or 3. Braces on new lines. This is primarily applicable to languages such as Java and C, where function contents and if statement contents are written within curly braces. Whilst it is entirely up to you, you may have seen a couple of code examples where you have an if statement and then the curly bracket opening the contents is on the next line. Whilst I personally find this horrendous, it is technically not wrong or right, so this is entirely up to you. It is just imperative that you stick to one way of doing it. Now, sometimes you may not need these braces at all, such as for instance if you have an if statement which only is supposed to execute a singular line of code. In those cases, it makes sense to either just entirely omit the curly braces and just have an indentation, so that you remember that this line of code is only executed upon the if statement, or that you even just entirely omit having it on a new line and just have a space after the condition. As far as I'm aware, this can help or destroy legibility. However, once again, it is one of those cases where you should try to find one way of doing it and stick to it. And the last thing on the topic formatting I will be covering are spaces between characters. You may have noticed that in programming, spaces are only to separate words, primarily. So technically, in all other cases, you should have no spaces at all. However, you will have noticed that this is not too great for legibility. In some cases, primarily in mathematics, there can be made an argument that it still makes sense to do, such as if you have a longer mathematical formula, you might want to remove the spaces between some of the additions and subtractions whilst keeping the ones between divisions so that it is easier to read this. Once again, this is entirely up to you. Okay, from here the process of actually learning a programming language should be more surmountable. To start this, I would recommend that you try to find some small project which should be easier to complete, and then consider how these concepts I have explained so far would be applied to this project. Then to actually realize the project, what I genuinely recommend is, after considering how it would be assembled from these concepts, I'd really just recommend using your search engine. Try to avoid using a large language model such as ChatGPT or Claude, as with those you will not learn anything, and instead try to use a search engine specifically such as DuckDuckGo, as the Google search really tries to stop you from using your brain at this point, and then just search up the individual concepts I've explained so far in the language you're working in. Furthermore, on screen there should currently be a playlist being recommended for teaching you how to work in C. If you're watching this just after the video has been released, then this playlist is not available yet, however it should be very soon.